We're going to finish lesson 33.1, where we talk about prisms and pyramids. And in today's video, we're talking mostly about the cross sections of those 3D figures. So open up your Springboard book. We're going to start on page 483. Okay, so we're going to describe properties and cross sections of prisms and pyramids. So we did the first part of this lesson today in class, so we're actually going to skip to part 2. Okay, which is on page 483, where we start talking about the cross sections of these 3D figures. So a cross section of a solid figure is the intersection of that figure and a plane. Okay, so essentially what we have is this. Now this picture is a little deceiving when we think about it, okay, because we learned in class that a prism, okay, which has rectangular sides, the base is the two parallel shapes that connect them. So really in this picture, our bases are these triangles. So even though it says the bottom of the solid, I feel like that's kind of confusing when they have it there. Because really we have a triangular base and rectangular sides. Okay? So when we talk about cross sections, it's like if we had this 3D figure and we stuck a piece of paper, like a thin piece of paper, in the middle of that shape, well, what kind of figure would that cross section make? Okay? So I have a couple links that we're going to look at here. So let me go to those. So we're going to start with this triangle prism. Now, this is facing the different direction than what your book has it as. You can see here that we have our triangular bases and our rectangular sides around, okay? But the cross section would be this plane, this kind of rectangular shape that cuts through that shape, okay? So the cross section would be this kind of dark brown figure here. Now, if we have a cross section that's parallel to our bases, so you can see we have our base here, and then our cross section, and then our base on the bottom. So when that's parallel and we move it, doesn't matter kind of where we put that cross section, we can see the shape of that cross section is going to be a triangle. It's going to be the same figure as the base. Okay, so going back to our notes, describe the two-dimensional shape of the cross section that is parallel to the base. Well, it's going to be a triangle because the bases are triangles. Okay. Describe the two-dimensional shape of the cross section that is perpendicular to the base. So let me go back to our little thing here. So if I rotate this, so now it's a vertical cross section. Okay, so now that cross section is perpendicular, going from base to base. Okay, perpendicular to the base, you can see what shape it's making. And even if I move it, okay, rotate it, or I move it left to right, okay, what shape is that making? Well, you could see it's the same shape as your side figures. It's going to be a rectangle. Okay. Now, we're going to talk about a different shape on the next one, which is a hexagonal right pyramid. So remember, hexagonal would be the base. So we have a hexagon, a six-sided base. Okay. And a pyramid means it all comes to a point. So a hexagonal pyramid looks like this picture here that I'll pull out. Okay, where your base is a hexagon, and all of those vertices line up at this top point up here. Okay, so looking at these different pictures, now these are different cross sections here. They want to say label each cross section as parallel or perpendicular to the base of a pyramid. Now, I have another link so we can kind of look at this with a hexagonal pyramid. Okay, so if we had something parallel to the base, okay, there's our cross section. So again, the cross section means we just kind of take a chunk or slide a piece of paper that runs parallel to that shape, and I can move this up or down. Okay, so going back to our notes, which two figures are going to be the ones that are parallel to the base? Okay, well, it should be this first picture because that is a hexagonal shape, and the smaller hexagonal shape. Okay, so the bigger one might be one that's closer to your base. That smaller hexagonal shape would be one that's kind of more towards the vertex of your pyramid. Okay, so that means all these other shapes are some that would be perpendicular. Okay, so if it's perpendicular, so let me go back to our picture so we can kind of visualize this. Perpendicular to the base. So here's one that when we move it, okay, it's going to look like the sides of your hexagonal pyramid, right? So that's why a triangle would be a cross section that's perpendicular. Now the other two are trapezoids. So let me show you how we get that as well. Okay, and that would look like this. So it's going the other side where you have kind of some vertex points. And again, I can move this trapezoid to make it taller, closer to the vertex, further away from the vertex. So it will make different trapezoidal cross sections. Okay. So that's why those would be a perpendicular shape, because if we think about this, if say we're looking at a cross section from this side, okay, that pyramid's going to go out at an angle, so that's why it makes that kind of trapezoidal shape. But again, if it's coming from the vertex, that's why it makes a triangular shape, because your sides are triangles. Okay. So we're just going to wrap this up on the next page, and you guys are going to do question 13 for me, where it says sketch several cross sections that are parallel to the base of a square pyramid. So I put a picture of a square pyramid here. Okay. Now, several cross sections that are parallel to the base. So think about what your base is. Go ahead and draw on several different types of cross sections that we could get from a square pyramid. Okay. Well, hopefully you picked all different sizes of squares. Okay. So again, the bigger the square, that means the closer it is to the base. The smaller the square, the closer it is to the vertex there. So that would be ones that are parallel. So let me move these kind of up here. Little square. Oh, didn't work. So this would be an example of something parallel. Okay. So now they want you to draw several cross sections that would be perpendicular, okay, to the base. So think about if you had a cross section that went perpendicular to the base. So that means it's going to run up and down, because perpendicular would create a right angle with the base. What kind of figures would you get from that? Okay. Well, let's look at our square cross sections here. So here is a square pyramid. So again, if it's parallel to the base, you can notice that if I shift this, even if I move it up and down, okay, the closer to the base, the bigger the square, closer to the vertex, the smaller the square. So it doesn't matter how we move it parallel, it's going to be the same cross section as the base, so a square. Now, if we tilt this to make it perpendicular to the base, you can see we have different shapes, right? We have a trapezoidal shape, okay? If I turn this, more trapezoids. And it's kind of hard to tell, but we should also get a triangle cross section as well. Okay. So what patterns do we notice? So the cross sections parallel are always squares, okay, because it's going to mimic the base. Cross sections perpendicular to the base are triangles and trapezoids. Okay, and again, the trapezoid comes from these tilted sides and having two shorter bases. So if we drew lines like a cross section that went here, like this. Okay, that's how we could do that. And again, we could also get a triangle, because this side, if we had something that ran parallel to the side, it's going to give you that same cross-section shape. Okay, so we will practice this more in class, but just know when we're doing a cross-section, it's like we took a really thin slice out of that three-dimensional figure.